Assalamu alaikum everyone. I hope you guys are doing well. So in this video, we are going to talk about the fourth unit of the first chapter of P3 Maths, that's Algebra. And we will be talking about the remainder theorem. So the remainder theorem is used in AS, in A2, and students who are preparing for their entrance test, they can also obviously they need to talk about the remainder theorem as well. So we are basically discussing one of the most popular and important topics of maths. Okay, so it's basically the remainder theorem and it's self-explanatory. It would be giving you the remainder. How exactly? Let's talk about the definition first and then I'll talk about the questions. So according to the theorem, it says when a polynomial f of x is divided by x minus a, the remainder is f of a. Let me just explain this part and then I'll talk about the next part of this theorem, okay? So according to this theorem, when a polynomial f of x, it could be any polynomial of this world. When a polynomial is divided by x minus a, the remainder is f of a. Now, the polynomial could be, let's talk about some examples. Let's say f of x is basically equal to 4x cubed plus x squared minus 3x plus 7. It could be that f of x is equal to 3x squared plus x minus 4. It could be anything, right? So this is what a polynomial basically is. And when this polynomial is divided by x minus a, it could be x plus 2, x plus 3, x minus 4, x plus 5, anything of that type. What is the remainder? So this is basically your dividend. This is our divisor, and this is going to give you the information about the remainder. Now, in general, when we talk about numbers, for example, if I say, what would be the remainder when I will divide 6 by 49, okay? And I need to do all the working, and then I just understand that the remainder for this type of a scenario is going to be whatever number we get at the end, okay? For example, if we talk about this one, this number right here, so we have 6 as the divisor and 49 as the dividend. So you will do 6 multiplied by 7, it would give you 42. And this is going to give you 7. So this means that we can obviously just do it this way. 1 second only. All right, if we talk about this one, so again, it is going to be 6 multiplied by 8, that gives you 48, right? So this is 1. So the remainder is 1 in this case. But here we are not discussing numbers. Here we are talking about polynomials and then their remainder, okay? So this is the idea about simple numbers, but what we are discussing are basically polynomials, okay? So this is going to be the remainder for this scenario. All right, let me just complete the theorem. I'll explain it furthermore, and then with examples, this concept would get very, very clear. Okay. All right. And the next part of the theorem is when a polynomial f of x is divided by ax minus b, the remainder is f of b by a. Okay, so what do you need to understand? You need to notice one thing. This is your factor or the divisor that you are dividing. Just equate it to 0. Ax minus b equal to 0, and it would give you x equals b by a. So you need to plug in x equals b by a in your f to find the remainder. Similarly, if we talk about x minus a, when you will equate x minus a to 0, you would get x equals a. Okay, that is why we are using this in order to find out the remainder. This concept would get very, very clear with the examples. Obviously, this way you would not be able to understand it that well. So let me just quickly write down an example. Okay, let's talk about example number 1. Okay, example number 1 says find the remainder when 4x cubed plus x squared minus 3x plus 4 is divided by x plus 2. So this is the question that we need to discuss right now. Okay, all right, now let's understand the question. Again, the question says find the remainder. So the question is about the remainder. That is why I would be using the remainder theorem. This is my polynomial. Now the examiner would obviously not say f of x is equal to this, like he can or he may not. It totally depends. Okay, the polynomial is given. It's 4x cubed plus x squared minus 3x plus 4, and this is your divisor. When this polynomial is divided by this thing, so here is our dividend, and this is my divisor. Okay, so this was some basic information, and again we are talking about the remainder. So let's talk about the solution. According to the remainder theorem, when f of x is divided by this, the remainder is f of a. So this time around, the divisor is x plus 2. I need to equate it to 0. And it would give me x equals minus 2. Now I need to find the value of f of minus 2. Let's just imagine that the polynomial is equal to f of x, and it is given it's 4x cubed plus x squared minus 3x plus 4. This is the polynomial. The remainder would be f of minus 2, and it is going to be 4 into minus 2 cubed plus minus 2 squared minus 3 into minus 2 plus 4. 4 into minus 2 cubed would give you minus 32. It would give you minus 8, and finally when we will multiply it would give you minus 32. Then we have plus minus 2 squared would be 4. Minus into minus would make it plus 6 plus 4. This would give you minus 32 plus 4, and then we have plus 10. And after simplification, minus 28 plus 10, and this would give you minus 18. All right, so this was basically the question. So here we had a polynomial and the divisor was x plus 2. In order to find the remainder, I did x plus 2 equals 0 in order to see the value of x. That turned out to be minus 2. Then I need to plug in this -2 in the function. So f of x was given. F of -2 would be 4 into -2 cube plus -2 squared minus 3 into -2 plus 1. 4 into -2 cube would give you -8. That was plus 4. Then plus 6 plus 4 minus 32 plus 4 plus 10, and then minus 32 plus 4 signs are different, so we would be subtracting -28 plus 10, and it gave you -18. So this was basically the answer for the first example. Now we know how exactly we are supposed to find out the remainder. Okay, all right, let's talk about another example and then let's see. Example number 2 says, when 16x power 4 minus ax cubed plus 8x squared minus 4x minus 1 is divided by 2x minus 1, the remainder is 3. Find the value of a. Okay, this is the next question which we need to discuss. All right, now some part is given, some part we need to find. When the polynomial, this is the polynomial, is divided by this divisor, the remainder is given. You need to find the value of a. This is a. Okay, so let's make the scenario. Now I know 2x minus 1 was the divisor, so I'll equate it to 0, and this would give me x equals 1 by 2. This means f of 1 by 2 would be equal to the remainder that is given. So it is f of 1 by 2 is equal to 3. This is basically the condition that I have. I need to plug in 1 by 2 in the function f, and I would get an equation with a as the only unknown variable, and that is how I would be able to easily find the answer. Okay, f of 1 by 2 would basically be 16 multiplied by 1 by 2 power 4 minus a into 1 by 2 cubed plus 8 into 1 by 2 squared minus 4 into 1 by 2 minus 1, and this thing is equal to 3. All right, let's just simplify this. So this would give me 16 multiplied by 1 by 2 power 4 is 16 minus a divided by 2 cubed is 8 plus 8 divided by 4. This and this would be cancelled. Minus 2 minus 1 equals 3. 1 minus a by 8 plus 2 minus 2 minus 1 equals 0. Also equals 3. I'm sorry. These two would be cancelled. These two would be cancelled, and I would get minus a by 8 is equal to 3, and a is going to be minus 24. This would be the answer. Now, one thing should be clear. Using the remainder theorem this time around, we did not calculate the remainder. The remainder was already given. We used the remainder theorem in order to find the value of one of the constants using the condition that if 2x minus 1 is the factor, x would be equal to 1 by 2. We will plug in 1 by 2 and that would give me the remainder, and the remainder was already given. So this was the condition that I used in the question. And after using this condition, I got an equation with a as the only variable. And after making a the subject, I got a equals minus 24. So this was basically the next example. All right. Let's talk about a few more questions. Example number 3 says, find the remainder when x cubed plus 4x squared plus 8x minus 3 is divided by 2x plus 1. So the polynomial is x cubed plus 4x squared plus 8x minus 3 and the divisor is 2x plus 1. And again, the question is about finding out the remainder. Let's talk about the solution. So this time around, I know the divisor is 2x plus 1 equals 0. And this would give me x equals minus 1 by 2. And the function is, or the polynomial is f of x, and it is equal to x cubed plus 4x squared plus 8x minus 3. So f of minus 1 by 2 would be minus 1 by 2 cubed plus 4 into minus 1 by 2 squared plus 8 into minus 1 by 2, and then we have minus 3. So it would give me minus 1 by 8 plus 4 divided by 4 minus 4 minus 3. This would give me 1. And finally, I would get minus 1 by 8 plus 1 minus 7. And it would give me minus 1 by 8 minus 6. And now we can just, find out the LCM. It would be 8 minus 1 minus 48, and it would give me minus 49 by 8. You can just find out the answer in decimals, or you can just write down the answer in mixed numbers. That would not make any difference, okay? But again, the question was simple. You had to find the remainder. This was the polynomial and this was the divisor. So this turned out to be x equals minus 1 by 2. This was f of x. We had to plug in minus 1 by 2 in f in order to get the remainder. After plugging in minus 1 by 2, we got this. And after simplifying, finally, we got minus 49 by 8 as the answer, okay? So this would be the answer. All right, okay. Let's talk about another example. All right, this time around the question says, when ax cubed plus 16x squared minus 5x minus 5 is divided by x minus 3. The remainder is minus 2. Okay, let me just write it down again. But it is divided by 2x minus 1. The remainder is minus 2. So it says find a. The polynomial is ax cubed plus 16x squared minus 5x minus 5. When this is divided by 2x minus 1, the remainder is minus 2, find a. This time around, yes, we would be using the remainder theorem, but not to find the remainder. Remainder is already known. We need to find the value of a, okay? So let's talk about the solution. 2x minus 1 is the divisor. I know in order to solve these questions, I need to equate the divisor to 0. And this would give me x equals 1 by 2. Now 1 by 2 is basically the value of x that I will be plugging in the function or the polynomial. The polynomial is f of x equals ax cubed plus 16x squared minus 5x minus 5. And the remainder would basically be equal to f of 1 by 2. So f of 1 by 2 would be equal to the remainder. This is the remainder theorem basically, right? All right. So yes. Now I need to find the value of f of 1 by 2. I already have the remainder. So my condition would be f of 1 by 2 is equal to the remainder, that is minus 2. And f of 1 by 2 is basically, this is the polynomial. So if f of x is ax cubed plus 16x squared minus 5x minus 5, f of 1 by 2 is going to be a multiplied by 1 by 2 cubed plus 16 into 1 by 2 squared minus 5 into 1 by 2 minus 5. Let's just simplify this. This would give me a divided by 8 plus 4 minus 5 by 2 minus 5, and finally I would get a divided by 8 plus 4 and minus 5 would give me minus 1 and minus 5 by 2. So this would be a divided by 8 and then minus 7 by 2. This is the value of f of 1 by 2. A divided by 8 minus 7 by 2. And I need to equate it to the remainder, that was minus 2. So this would become a by 8 equals 7 by 2 minus 2. So a by 8 would be equal to 7 by 2 is 3.5 minus 2 is 1.5. So I can write it as 3 by 2 and I can take this 8 there. So this would give me a equals 3 multiplied by 8 by 2. This is 4 and this would give me a equals 12. So this is going to be the answer. So again for this question, we did not use the remainder theorem in order to find the remainder, but in order to find the value of a. Okay, the idea was the polynomial was given, that is the dividend, the divisor was given, that was 2x minus 1, and the remainder was also given. So using the remainder theorem, I was able to make this equation. or this conditional equation rather. And after plugging in 1 by 2 in x, I got this, and the remainder was -2. So this was basically the equation. And after making a the subject, I got a equals 12. So this is how we use remainder theorem. So if I give you a quick recap of whatever contents we have discussed today, you should know that according to the remainder theorem, if you have a polynomial, think about it as your dividend. If you have a divisor, when you will divide the polynomial by the divisor, the remainder would be f of a. Okay. Now, whenever you come across such type of a question, just take your divisor. Here is your divisor, equate it to 0 and find the value of x. So it turned out to be x equals -2. Use this x, plug in this value of x in the function, simplify it, and this is going to give you the answer. Okay. If I talk about the next example, here we use the remainder theorem in order to find the value of a. So we had the polynomial, we had the divisor, and we had the remainder as well. Using the remainder theorem, I got this as my condition. And finally, I was in the position to make a the subject, and after making a the subject, I got a equals -24. Then again, we use the remainder theorem directly to find the remainder. So this was the divisor. I have equated it to 0, and I got x equals -1 by 2. Now this value of x was basically plugged in over here. So when I will plug in it, when I will use x as -1 by 2, I'll use x over here as well. I'll use -1 by 2 here as well and here as well. I've simplified and I got -49 by 8. Okay. So you can convert this to mixed number or to decimal. This totally depends upon the question the examiner is asking. And in the end, the question was again solved using the remainder theorem, but we did not find the remainder. So this time around, it said the polynomial was given, the divisor was given, the remainder was also given, and you had to find the value of a. So again, this was the value of x, this was f of x. Using f of 1 by 2 equals -2, using the equation, I made a the subject and it turned out to be 12. So these were some examples from the remainder theorem. If you were not able to understand anything, if you have any confusions, any queries, feel free to ask me. And if you are interested in the live classes where we are covering the entire syllabus and everything, just use the link in description to get yourselves enrolled for the live classes. All right. So thank you very much. Take care and Allah Hafiz.